or to infinity. Nice thing is this one just said find the limit. Okay, so number 11. If you were doing the degree test, your final answer should have been -1. Why? Because the degrees were tied. The degrees were tied. Another way of thinking about it is taking your two champions and saying, hey, the end behavior model, does that stand for anything bad? Hopefully not, would be g of x is equal to -x all over x, which equals simplified -1. Yay! So this guy to infinity will act like that. Nothing weird with absolute value, so actually the positive or negative infinity would have been the same thing. But I saw in the hands of some of you that multiplied top and bottom by 1 over. You did it the mathematical way. And you would have gotten the limit as x goes to infinity of 1 over x minus 1 all over 1 over x plus 1. Those would go to 0. Those would go to 0. -1 over 1 is -1. However you did it. The limit is -1. What does that indicate about horizontal asymptotes? Yes or no? Yes. And where would the horizontal asymptote be? Not x equals, careful. That's vertical. Y equals -1. Okay. Number 18. If you did degree tests, you should have said none. Just kidding. That's the answer to horizontal asymptotes. No horizontal asymptote, but that is not the answer to the limit. Why no horizontal asymptote? Because who wins? Numerator. Good. The top wins. The numerator is stronger, right? His champion is greater. We're thinking about champions and end behavior models. The end behavior model would have been g of x equals 4y to the 4th all over y squared, which equals 4y squared. This guy's gonna, this whole nasty thing's just gonna act like that parabola. Why is that cool? Couldn't you think of what that parabola would be doing to positive infinity? Or to negative infinity? So much easier than even thinking about that guy. But if you did think about that guy, if you did think about plugging in infinity and saying the top is winning, hopefully you would have still gotten positive infinity as the limit where the y's are headed. As you go, specifically this one's asking to the right. For those of you guys that would have done the degree test, sorry, not the degree test, the multiplying by the algebraic approach, hopefully you would have multiplied by 1 over y to the 4th. Do you guys realize that I can take limits as any variable goes to, not just x? It can be y, it can be t, it can be beta, it can be all sorts of stuff. They work the same way. So 1 over y to the 4th, the same way I did 1 over x up there is the strongest power. You would have had 4 all over 1 over y squared plus 3 over y to the 4th. Whoa, this is confusing. It's a number over 0. That's something in math. Number over 0 is what we used to call. Yeah, what we used to call, we still should call, infinite form. Infinite form, and it was a way to distinguish a whole from a vertical asymptote. A whole is going to be seen by plugging in the discontinuity to a function and seeing 0 over 0 indeterminate form, whereas a vertical asymptote is going to be seen by plugging in and getting a number over 0 infinite form. That had to do back when we were with rational functions, the fraction-y dudes with really nasty polynomials on top and bottom that we could or sometimes couldn't factor. Anyway, chapter 1, chapter 2, something like that. Number 27. Number 27. Dun, dun, dun. Did you guys get -5? A couple different ways of doing it. A couple different ways of doing it. Which means there is a horizontal asymptote at y equals -5. But this one, you could say bottom wins for one of the guys. Then you could say it's high for the other guy.
So wait, what happens to the first one on the bottom?
Huh?
What happens to the first one on the bottom after you can't put it?
Well, let's check it out. If you were to take this guy piece by piece, you could have thought about him separately from him. Because limits say we're allowed to, for addition or subtraction, take the limits piece by piece. So if I'm just looking at this guy, wait a minute. who were my, remember my champions? Who are the champions for 1 over t squared? Those two guys, right? And my champions here are those two guys. Now, bottom wins, yeah? And if bottom wins, well, he goes to 0. Or you can think of 1 over somebody squared. That's actually somebody that we should know. He's this graph. 1 over x was like this. 1 over x squared is like this. He was a basic graph of a parent graph from a long time ago. And what's he do to infinity? He gets closer and closer and closer and closer to the x-axis, which is 0. So approaching 0. This guy, Robbie, you're wondering about the +2, right?
Yeah, I just think.
Champions, we only look at the David and Goliath, not the rest of the army. Cool. So then when we have a tie, technically that means our end behavior model would have been 5t over t, which is 5. Now guys, this is something actually Calc AB kids mess up quite a majority of them, usually on a test, the first chapter or second chapter test near the beginning of the year. A question like this, because they get confused. They're like, it's not all one function. And some of them get the 5, but they forget the minus. Why does it have to be a -5 and not just a normal 5? You have to put it all together. It'd be 0 minus 5, right? Which is -5. Okay. Those of you guys that would have done the algebraic approach, you actually shouldn't have done the algebraic approach yet. You should have actually gotten a common denominator first if you were going the algebraic way. So this guy would have had to get a t plus 2 on top to join with that guy, because you're trying to get a common denominator of 3t squared and t minus 2. And then this guy would have had to get a 3t squared, which would have been 15t cubed. And who was your champions? Well, I guess we could have done champions here also. If we had done champions, we would have had the negative 15t cubed. And then you guys see how if we distribute, that guy ends up being a 3t cubed? Then you could have gotten -15 for another end behavior model. If you had gone this route, that would have been 15t cubed all over 3t cubed with the negative in front. Ooh, that's still -5. Ha-ha! But my algebraic people, wouldn't you have multiplied by 1 over t cubed at this point? Would have worked out. Final answer, -5. Questions? Yeah.
For 18, if it was like on a test or quiz, would the answer choices, would they be infinity or would one of them be like
If it was a long answer, the best answer to put would be infinity. If it's multiple choice, you would not have infinity and DNE as an option. So you would choose the best answer. Why is Adam saying, wait a minute, you said infinity, but what about DNE? Because in air quotes, the limit does not exist. No, it's going to infinity. I know. But is infinity a single constant? So the AP exam would say infinity. Back of your book might say DNE. But let's check that now as we grade homework, right? Because I think that's part of where this is coming from, right, Adam? All right, here we go. You guys can see, I think, all the evens right here. My mic has been weird, so I have to keep on making sure the battery doesn't start dying. If you guys see this thing flashing at any point during class, just let me know. It's like a little orange light that comes on. Right, we talked about sequences at the very end with converge and diverge, huh? Cool. That's a fun thing about pre-cal, especially honors pre-cal, because we get to introduce all sorts of stuff. Calc AB, Calc BC, physics, statistics, probability, vectors, higher physics. Linear algebra with matrices. That's something that a lot of computer programmers, it used to just be like a kind of random course with computer programming, computer science, linear algebra, matrices. I've gotten more and more important. Used to be, I was like, why was I covering matrices? It's really important, but these days. right, I'm opening up the book to section 12.4 just in case. I think for the sequences ones, I think I mostly assigned odds, just so you guys could check, but I did assign that one even, number 48. Do you guys feel accomplished that we're at section 12.4?
No.
And how do you skip one chapter? If you're like, gosh, I feel cheated. It's okay. Still have a couple weeks. You can study chapter 11 on your own.
Nice.
Would be helpful for a physics 1, physics 2 course. All right, any questions on the evens that you see ahead of you, in front of you? Any questions on the evens? Any questions on the odds? Do any of these have DNE? No. Do you have one from homework, Adam, that was a DNE? Like they said it, but I would have said something differently?
There was one where it was just for
Trying to peek real quick. I don't remember what I gave you. Does anybody have, like, looking at your homework, the evens and the odds real fast, does anybody have a problem whose answer, a limit whose answer was positive or negative infinity or DNE? Number 17? Oh, yeah, 17's a good one. Uh-oh, it's taking forever. I'm sorry. Come on. Wakey, wakey, webcam. Wakey, wakey. Okay, well, while the webcam is taking forever, I think I could just write it faster. Oh, no, that's not working either. Well, Hey, you never know. Someday, technology in my classroom might just randomly start working. Okay, so.
Wow, that's beautiful.
Wishful thinking, I think, is what that is. Okay, so, limit. Oh, it is working now. But so is my webcam. Okay. Oh, and it did twice. And there's a warning. Let's just get rid of the warning and ignorance is bliss. Was helpful? Nah, that's no fun. If it was helpful, it's something that I, as a non-admin, could probably not affect anyway. So, there we go. Okay, 17. As you guys check this guy out, my question to you is the following. Who's the champion of the numerator? Yeah, there's only one guy in the numerator, so hopefully he's the champion. Like it or not, he's going to be used as the guy. T squared, and then who's the champion at the bottom? T. So the end behavior model, T squared over T. Doesn't that just reduce to be T? And doesn't T look like this, where he's going to positive infinity as you go to the right and negative infinity as you go to the left? Some of you are like, what on earth are you talking about? I'm talking about my end behavior model and how this nasty dude right here is going to behave like T squared over T. And then I'm like, oh, hey, I can take away the T and take away the squared, and this guy's really just T. And T, y equals T, is a guy with an intercept at 0, 0, bloop, 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 and a slope of up 1 over 1, up 1 over 1, up 1 over 1. Okay. Is this to the right or to the left? To the right. So, the answer would be positive infinity, but what did the back of the book probably say? My guess is DNE. Why? Because that's not a single number. Okay, fine, it's not a single number, but what's the best answer? Positive infinity. But could you put DNE?
Sure. Why not?
Is that good? Well, the idea exists, but does the number, the single number, exist? No. So, okay, if I can do DNE, but it's infinity. Okay, any other questions on homework? I'm going to go use my mouse to get rid of Windows. Yeah, Gavin.
51.
51. Is that one of those sequency ones?
Yeah.
Let me not close this. Ooh, factorials. We've learned that this year too.
Whoa.
Still BC. Thought we might get into another class. 51. You guys had to go back to when we reviewed factorials for this guy. Factorials, how do they work? 5 times 4 times 3 times 2. No, I taught you better than that. Factorials, how do they work? Don't work backwards, work forwards. So instead of 5, 4, 3, 2, 1, instead it's going to be much more productive to do 1, 2, 3, because then you can say, oh, I don't know who that guy is, but he ends there. Wait a minute, why did I leave an awkward space? Well, this one's going to be 1, 2, 3, all the way up until n. But don't you always add 1 when you're doing a factorial?
Yeah.
So what would have been next, even though it's not, because n's the last?
Oh
Look
my
at that.
goodness.
So all of those cancel out, and all I have to worry about is
N plus 1.
t equals that.
Boom,
So all I have to do is the limit as n goes to infinity of n plus 1. Oh, I don't know. There's not a denominator.
0.
Plug in
1.
Plug in infinity. Add 1. Still infinity.
What?
Or if worst comes to worst, okay, you can add a 1 as a denominator. Kyle just didn't finish his thought. So you can put a 1 in the denominator and say, he's the champion, he's the champion. Who wins? Well, not him. He's going to infinity. Dun, 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 dun. Or wait a minute, what are you supposed to be answering? I think the word converge or diverge, right? So if the sequence is going to infinity, what word should I use? Diverge. Not divergent. Well, I guess you could use that. Anyway, that was so like 5 years ago.
So like
7 years ago? No.
I don't know.
I know what class it was. It was Sarah Alice, Stephen Phillips, and Zach Stone. That would have been, they graduated from college last 2 years ago.
Whoa.
6 years.
6 years ago?
But I think she was reading the books before that. And then these came out. Anyway, go team. Here we go. Any more questions on homework? Going once. Going twice. Sold. Okay, let's go ahead and go to section 12.5. Guys, look at the backboard. Where are we going?
Somewhere.
71.
I don't know when.
We are going to homework 71. It's been posted on Google Classroom. Boop, boop. Due on, I haven't written it. Sorry, due on Wednesday.
When is it tomorrow your AP this week?
It is my AP. Doesn't mean we're going to slack off. All right, so, woo! Got to keep you guys sharp. We're going to area. What? Area.
No.
We were just doing tangent lines. What? Limits. Oh, that's right. We were just doing limits. And then we use them for tangent lines because what special limit leads to tangent lines?
Why is it with my head? Derivative. Thank you.
The difference quotient. The limit as h goes to 0 of the difference quotient. Why am I writing it up? Because it'd be good for AP Calc kids to remember this too for tomorrow. So by the end of this year, there are 3 big concepts in calculus. You will have seen kind of one of them. Little itty bitty pieces of the other 2. Because this guy has to do with integration. This guy has to do with differentiation, aka derivative, the act of taking the derivative. And then this one has to do with limits. 3 big concepts in calculus, and you will have been introduced to them all. Why? Because limits. We did limits to constants as x approaches c, as x approaches 2, with graphs and with tables and with algebra. Plug it in, or play. Keep going. Limits at, or is it to infinity, horizontal asymptotes, degree tests, algebraic approach, etc., etc. Tangent lines. Limit as h goes to 0 of the difference quotient and how to deal with that derivative. You've dealt a lot with limits. The title of chapter 12 in your book is Limits and an Introduction to Calculus. We've done limits. And how we introduce calculus. Well, the whole tangent line thing. Hey! The whole tangent line thing has to do with that topic. And then guess what the whole area thing has to do with?
Oh my god.
That topic. I know this was not for you. This was for calculus kids having in front of them in their faces that they couldn't even ignore unless they purposely had to fall asleep in class to not look at it.
It was a
The things that I needed them to remember for tomorrow. That's it? No. Not even close. But these are the big ideas behind all the other stuff that they do. Cool.
What's the big idea?
Okay. Area.
7 and 85 36 is a particular calc AB.
Unless they change the schedule, we can do that. But possibly. You're gonna start a countdown today.
Oh no.
365. All through 7?
No.
Don't worry, I'll let you know the first day of school, how many days till it. Okay, the area problem, Mrs. Choi, part 2. Didn't you have a countdown on her website all year for WAP last year?
No.
A lot of your sophomores.
Miss Choi didn't do it.
She didn't do a countdown? Oh, she did for English. Maybe she stopped it because kids are stressed. This year's juniors are quite a stress bunch.
Oh, yeah.
Oh, I think sophomores are. And seniors are as well. Just takes 1 year to be like, we gotta chill. Work hard, but not with stress. Anyway. Is that possible? Area. Area. Going back to summation.
Ew.
What? Do you see sigmas? Oh my goodness, so many things from math just keep coming back.
Bad examples.
Okay, what you see right now is sum of an infinite geometric series. You are going to learn the definition of the integral. Which, to be honest, not even AB kids need to know. BC kind of do.
Really?
Yep. Remember, it's pre-everything future math. Sum of an infinite geometric series. Do you guys see that he's geometric? How can you tell he's geometric besides the fact that I say he's geometric?
Because the formula A1 offset are raised by.
Okay, so some of you remember a sub 1 r to the something. Some of you remember the a1 over 1 minus r something. But maybe it's a little bit easier just to say, of course it's geo. What's happening every time? Times r. Times another r. Times another r. Times another r. Where r is the common ratio. Where a sub 1 is the first term. And where... that's good enough. Okay. So why on earth would the sum of an infinite geometric series apply now? And why on earth is the word limit being used right away? Because of what I already showed you. Oh, you already showed us this. Old school, it's old stuff, old stuff. But it's good stuff. I just showed you earlier. How do you solve an infinite sum? You take a limit, of course. No, you plug infinity as the top bound. Do you know how many times I hear, where's the infinity button in my calculator? You guess what I respond with? It's an approach. It's not a number, so you can't plug it in. Thank you. It's an approach. It's not a number, so you can't plug it in. So what do you have to do? Take a limit. Because that's the only thing that approaches in math, right? At least nowadays. Used to be a time there was no such thing as a limit. Or the idea of infinitesimal. That's for a limit approaching a constant. There was a huge philosophic debate between these monks.
Is there infinite?
No, it wasn't so much as their infinity. I'll try to explain it a little bit better as we go a little bit further. Dr. Mary gave me an article from a journal once that kind of explained it. I still have it. How do you go to infinity? You approach it. Oh, okay, so we need a limit. Now you know, hopefully. Whenever I say the word approach, you're like, oh, so there's a limit involved? Yeah, there's a limit involved. I need to go ahead and say, okay, in a sum, technically, sigmoid notation says, give me a lower bound, give me an upper bound. Infinity, even though it's there, we would call it technically an improper sum, sort of. There are these things called improper integrals too, but that's BC. But anyway, we would call it improper because technically infinity is not a number. We just talked about that, right? So the proper proper way to state this would be 1, 2, an upper bound, an actual constant, an actual stopping point, n, and then put off to the side, and I need n to keep on getting bigger and bigger, please. Oh. And for geometric series, we can actually do this because there is a formula for, right, the sum of a finite geometric series. This is the a sub n, no, s sub n. This is the S sub n formula being plugged in from geometric series. It was something we memorized way back in the day. Tell me you recognize it.
Yes, I recognize it.
Thank you. Hopefully that was the truth. So, a sub 1 times 1 minus r to the n. Not questioning your integrity, just knowing it's been a while. Meaning like 2 chapters. Anyway. But what do I put in front? The limit as n goes to infinity. And off to the side, well, the limit as n goes to infinity of r sub n equals, if r is less than 1, which means r is in between 1 and negative 1, because that's the magnitude of r, that's the absolute value of r. Wouldn't that be fractions like 1 over 3, or 1 over 5, or 1 over 10, or 1 over 1,000? And if I raise 1 over 3, 1 over 5, 1 over 10, or 2 over 3, or 9 over 10, or negative 122 over 123. All of those are in between 1 and negative 1. What's going to happen as we raise those to higher and higher and higher powers because the bottom is going to keep winning?
Well.
So what can we do over here? All right, algebraic ones. You've already been practicing this a lot. We say, oh, he goes to 0. Only when r is in between 1 and negative 1. Otherwise, he'd be going to infinity, and that kind of blows the whole thing up and says, forget it, he doesn't converge. But as soon as that is done, we get back to that a sub 1 over 1 minus r. Formula. Maybe one of these days I'll remember that maybe this could be a great unveiling of, hey, it's the formula and why it appears, and maybe I shouldn't introduce to you the LIM early. But some part of me just wants to get to calculus as soon as possible, so I just can never wait. Anyway, a sub 1 over 1 minus r is the sum of an infinite geo-series if
It's between me and 1. R.
The geo-series is convergent, which will only happen if r is in between 1 and negative 1. So,
Yikes.
What if we're not dealing with an infinite geometric series? Because, pause, can I go back for a second? Oh, please go back. It's not going to go back. Oh, it did. It went. What was the key to me being able to take a limit of this sigma? What was the key to my being able to take the limit of this sigma? To rewrite the sigma as a formula with n's. Without being able to rewrite the sigma as a formula of n's, I can't go plugging infinity in. Oh, I can plug it in there and be like, I still have no clue. But if I can rewrite the sigma as a formula of n, then I can take the limit and use all of our, not infinite, just kidding, all of our knowledge of limits at infinity to try to solve. But without this step, we're sunk. And in Calc AB, this guy doesn't really come up besides the confirmer card saying, hey, this means this, and just stop there. Which is why we don't really have to go about the definition of the integral. But for you guys, we've done sigma, so hold on, I think we can do this. These are different sigma, or I should say summation formulas, where if we have, we can substitute. If we have, we can do. If we have, we can substitute. If we have, we can substitute. If we have, we can do. Because without being able to break down and substitute for sigmas, it will be impossible to take limits without using some sort of technology. Yes, we're getting to the idea of area, just probably not today, probably more like tomorrow. But here's the idea of homework. The idea of homework is all going to revolve about we need to do these infinite sums, and we cannot do these infinite sums unless we use limits, and we cannot actually do the limits until we take the sums and somehow get to express them as formulas. All of this we're going to have to build on for tomorrow, but it's pretty exciting that we are in the big idea of calculus number 3, just an introduction, of course. Limits and introduction to calculus. We are there. P.S. This is the last section. All of chapter 12.
You're right, Daddy.
Woo! Which means the test is coming. However, I'm debating throwing in just a little more calculus before the test or after. So we'll see. Because right now I think I have your test on Thursday. And what do some of you guys have on Thursday?
AP.
Wow. So I'm thinking maybe I'll throw in like power rule practice and maybe another derivative shortcut rule practice and like extend the chapter a little bit. Have the test maybe more like Friday and Monday.
Yeah.
Friday's kind of the day after WAP. That's rough. We'll see. We'll talk
Monday
tomorrow. I'll figure it out. Sound good? Peace. Chapel time. Mr. Lonnie Jones. It's going to be a good day. Bye, guys.
Who?
I'm pretty sure it's Mr. Lonnie Jones. I'm excited. Because I didn't get to hear it Shepherd the other day.
Who's that?
Mr. Lonnie Jones. Noe Lonnie. Noe Lonnie.
I was speaking German for a second.
You see. Hold on.
It's this in front, right?
Yes.
What?
Put your